Hello everyone, it's the Chemistry Kid here, and today we're going to learn how to determine the number of valence electrons in different elements. So knowing how to determine the number of valence electrons is important because they are the electrons in the outer shell of an atom. In other words, these are the electrons that are actually involved in reactions. For example, if a neutral element becomes a cation. To start off, let's learn how to determine the valence electrons in main group elements. In other words, what we're going to do is we are not going to focus on these elements here, which are the transition metals. We are going to be focusing on these two groups and the rest of these groups over here. So the determining the number of valence electrons in these main group elements is actually quite easy because what we're going to do, we are just going to look at the group numbers. So I want you to just remember that this is group 1, this is group 2, and I know that this says 13 and 14 and 15, but the main thing that I want you to look at is the 3 in the 13, the 4 in the 14, the 5 in the 15, and so on. Because if we were to replace this 13 with a 3, this 14 with a 4, and then 5, 6, 7, and 8, we already know how much valence electrons are in each of these elements. For example, this whole group over here has 1 valence electron because they're in group 1. And this whole group over here has 2 valence electrons because they're in group 2. And looking over here, this whole group has 3 valence electrons, 4, 5, 6, and so forth, until you get to the noble gases, which have 8 valence electrons, because they are in group 8, or what's commonly written 18. So once again, I don't want you to worry about these elements here. We will go over that. We will go over the transition metals. For now, you already know how to find the number of valence electrons in these elements over here. So let's go over an example. What if I were to ask you how many valence electrons are in neutral boron? So boron has the symbol B, and if you look at the periodic table, boron is over here. And what group is this in? This is in the group number 3 or 13. But we know that this group here has 3 valence electrons. Therefore, boron has 3 valence electrons. And now you should be able to go through that process for every single element in the main groups. So in these groups here and in these groups over here. Now, moving on, this is where it becomes a little more complicated. Depending on what grade you're in, or whether you're in college or high school, you may not have the knowledge to figure out the valence electrons in transition metals. So if this is the case, you can skip this part and just end the video here, but I still do recommend that you listen and try to figure this out. So to find valence electrons in the transition metals, or this big section over here, it becomes a little bit more tricky. Now, as we said, the valence electrons are the electrons in the outer shell of the atom. So the main thing that we need to look for is we need to look for the electron configuration of the atom that we're looking at. For example, if we are looking at cobalt, we can use our prior knowledge and we know that the electron configuration is written like so. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d7. Now, as I said, you might not have the knowledge to do this, but here we are looking at different orbitals. So these would be in s orbitals. These are in the d orbitals, and these are the p orbitals over here. So cobalt has that electron configuration, but because the valence electrons are in the outer shell, the strategy that we're going to use is we are going to come up with a shorthand configuration. So a shorthand configuration of this up here. And the way that we do that is we need to find the preceding noble gas. The preceding noble gas. And as we know, noble gases are very stable, and they're in the last group over here. So if we look at cobalt and we go across the periodic table like this, and then we eventually get to cobalt, the noble gas that's right before cobalt is argon, because if we continue after argon, we end up in the row of cobalt, and then we continue across. So what we'll do is we will put argon in brackets here, and this argon actually has this electron configuration up here. Argon has this electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6. And this leaves us with the remaining 4s2, 3d7. So after this argon in brackets, we write 4s2, 3d7. So this is the short form configuration, or the shorthand configuration. And these remaining electrons, this 2 electrons in the s orbital and these 7 electrons in the d orbital, these are after the preceding noble gas. So they're after the very stable noble gas. So these 9 electrons are considered valence electrons because they're in the outer shell. They're after the preceding noble gas. So therefore, cobalt has 9 valence electrons. Now, if you know how to come up with these electron configurations, I want you to try and figure out the number of valence electrons for a few other elements in the transition metals. If not, once you know how to determine the electron configurations, you will then have the knowledge to figure out the shorthand configuration, and then figure out which electrons are after the preceding noble gas, which in this case is argon, and then figure out what are the outer shell electrons, or what are the valence electrons. In this case, cobalt has 9 valence electrons. So as you know, the main group element valence electrons are relatively easy to figure out. But once you get to the valence electrons in transition metals, you need to have a little bit more knowledge to determine the electron configuration, and then the shorthand configuration. And then using the preceding noble gas, you determine the electrons after the preceding noble gas, and those are the valence electrons. Be sure to subscribe to my channel and comment below any questions that you might have. I'll try my best to get back to you guys as soon as possible.